Assalamu alaikum warahmatullahi ta'ala wa barakatuh. In this video, we're going to talk about the mean value theorem of a continuous function on a closed interval AB. So let f be a continuous function on AB so there exists M and capital M belongs to R such that fx is between M and capital M for all x belongs to AB. Now let's take the integral of each part of this inequality between A and B. So the integral between AB M dx is less or equal than the integral of fx dx capital M dx. We know that the integral of constant is mx between AB, integral of fx dx is less or equal than mx between A and B. We will find that if we replace by b, mb minus ma is less or equal than the integral of fx dx less than capital M b minus capital Ma. So the integral from AB dx is less than m times b minus a more than m times b minus a. Now we will find that 1 over b minus a, integral from a to b fx dx, is less than capital M more than m. Applying the intermediate value theorem, we'll find that there exists C belongs to AB such that FC is exactly 1 over b minus a, the integral from a to b fx dx. The number fc that equals to 1 over b minus a, the integral from ab fx dx, is called the mean value of f. Example: let's calculate the mean value of fx that equals to x minus 1 exponential x on the interval I equals 0, minus 1, 0. To do that, we need to calculate 1 over b minus a, the integral from ab fx dx. This is the mean value. That equals to, b here is equal to 0. So it's going to be 1 over 0 minus 1. The integral from 0, from minus 1 to 0 of x minus 1 exponential x dx. So the intermediate value is 0 minus 1 is 1. So it's the integral from minus 1 to 0 x minus 1 exponential x dx. We will use the integration by part to calculate this integral. So let's put ux equals x minus 1 and v prime x equals exponential x. Now let's calculate u prime. U prime is equal to 1 and vx equals to exponential x. That means the integral from minus 1 to 0 x minus 1 exponential x dx is equals to x minus 1, the primitive, times v times exponential x from minus 1 to 0 minus the integral from minus 1 to 0 exponential x dx. This is equals to, if replaced by 0, we'll find minus 1, exponential 0 is 1. Now if replaced by minus 1, minus 1 minus 1 is minus 2, so it's going to be plus 2, exponential of minus 1. And we know that the primitive of exponential is exponential, so if we replace by 0, it's going to be exponential 0, which is 1. So 1 minus exponential of minus 1. This is going to be minus 1 plus 2 over e minus 1 plus 1 over e. This is exactly minus 2 plus 3 over e. This is the mean value of this function fx that equals to x minus 1 exponential x, noted by this character called nu. Paragraph number 4. Calculating the area using integration. Let's start with the part 1. Calculating the area under a curve of a continuous function. Know that from the previous paragraphs, the area between the lines of equations x equals b and x equals a of a continuous and positive function so this area is the integral from a to b fx dx. But if a function is negative, so if we take a negative function means that its curve is under the x-axis, So it's going to be something like this. If you want to calculate this area, all we need to do to apply this integral is to multiply this function by minus 1. So it's going to be above the x-axis and taking the same shape as f. Now we will find that the area is the integral of minus f. This is minus f and this is f. So this area in green is exactly the integral of minus f. The third case, if we have a function that is sometimes positive and sometimes negative, like this one for example, between b and a, what we need to do here is to multiply each negative part by minus 1 to find the symmetric which is positive. The function that do this is the absolute value. So all we need to do to calculate the area between CF and the lines of equations x equals a and x equals b on the x-axis is to calculate the integral of the absolute value of fx dx. So let's f be a continuous function on an interval AB. The area between CF x-axis and the lines of equations x equals a and x equals b is the integral from a to b fx dx. Of course, we need to add the absolute value, so that this area is going to be positive. If we remove the absolute value, it's going to be called the algebraic area. The algebraic area can be negative, but the geometric area should be positive always. We know that the area needs the units. So what is the unit of this area? It depends on the xy plane. If we take an OEG, an orthogonal plane, the norm of I is equals to the norm of G equals to, for example, 2 centimeters. So the unit is the area of the square with 2 centimeter length. So this is our unit. So it depends on the exercises. For that, let's take an example to understand more. Let f be a function defined by fx equals x. We need to calculate the area between the lines of equations minus 1 and 2 of this function. So all we need to do is calculate the integral from minus 1 to of the absolute value fx dx. But before that, let's take an OEG plan such that the norm of E, or norm of I, is equals to the norm of G equals, for example, 3 centimeters. So the area between CF and x equals a x equals b and x-axis is the integral from -1 to 2, the lines of the absolute value of x, the absolute value of fx is the absolute value of x. To remove the absolute value, we need to know the sign of what is inside the absolute value of x. We know that x change sign between 0 and 0, so all we need to do is apply shell formula between -1 and 0 of the absolute value of x dx plus the integral from 0 to 2 of the absolute value of x dx. We know that between -1 and 0 x is negative, so the absolute value of x is going to be minus x. -1, 0, minus x dx plus integral from 0 to 2. Absolute value of x in the interval 0 to 2 is positive, so the absolute value of x is x. The primitive function of minus x is minus x squared over 2, from -1 to 0, plus the primitive function of x is x squared over 2, from 0 to 2. If we replace by 0, we'll find 0 minus, so it's going to be plus -1 squared is 1 over 2. If replaced by 2, it's going to be 4 over 2. Now the unit of this area is going to be 3 centimeters times 3 centimeters. So it's going to be 3 centimeters square. So 1 over 2 plus 4 over 2 is 5 over 2 times 9 centimeters square, which is 45 centimeters square over 2. This is the area between CF and the lines of equations x equals -1 and x equals 2. The second part is calculating the area between two curves, of two continuous functions. So let's take, for example, a function, its curve is like that, another one with a curve like that, between A and B, A, let's call the function in black CG, and red CF. So the area between CF and CG, and also the lines of equations x equals A and x equals B, is the integral from A to B, the absolute value of fx minus gx dx. Exercise. Let fx equals x squared and gx equals 3x minus 2. And OIG is an orthogonal plan such that the norm of I equals the norm of G equals 2 centimeters. First question, calculate the area between CF and the lines of equation x equals a and x equals b and x-axis. So let's take a equals, for example, -2, and the other line is equals to 3. Second question, calculate the area between CF and CG and the lines of equation x equals -3 and x equals 2. Thanks for watching. Do your exercise. See you in the next video.